Article 220.82b and Article 220.84 address different aspects of electrical load calculation in dwelling units, and they are not intended to be combined in the manner suggested. Article 220.82b specifically deals with optional feeder or service load calculations for dwelling units. It provides a method to calculate the service or feeder load of an individual dwelling unit by applying certain demand factors to various loads within the unit. These demand factors are based on the understanding that not all loads in a dwelling unit will operate at their maximum capacity simultaneously. Article 220.84, on the other hand, is concerned with optional calculation for multifamily dwelling units. It provides a method to calculate the service or feeder load for a building containing multiple dwelling units. This calculation takes into account the diversity of loads among the different dwelling units, recognizing that not all units will be drawing their maximum power at the same time. The load factors in Article 220.82b are applied to the total load served by the branch circuit. The load factor in Article 220.84 is applied to the total load served by the feeder. Combining these two would result in an incorrect calculation. The key distinction to understand is that Article 220.82b is intended for individual dwelling units, while Article 220.84 is intended for multiple dwelling units supplied by a common feeder. These articles address different levels of aggregation in the electrical system. Firstly, Article 220.82b focuses on the load within a single dwelling unit. Secondly, Article 220.84 focuses on the combined load of multiple dwelling units. Applying the load factors from both articles to the same circuit or feeder would lead to an inaccurate assessment of the actual load demand, which could result in undersized conductors, overloads, and potentially unsafe conditions. The purpose of load calculations is to ensure that the electrical system is adequately sized to handle the expected load while also avoiding unnecessary oversizing, which can lead to increased costs. By applying the appropriate load factors for the specific type of installation, electrical engineers and contractors can design and install safe and efficient electrical systems that meet the requirements of the National Electrical Code. To correctly apply these articles, you must first determine whether you are calculating the load for a single dwelling unit or for a building containing multiple dwelling units. If you are calculating the load for a single dwelling unit, you should use Article 220.82b. If you are calculating the load for a building containing multiple dwelling units, you should use Article 220.84. If you are calculating the load for a branch circuit within a dwelling unit, you would typically use the general load calculation methods outlined in Article 220, Part Roman 3, which covers branch circuit load calculations. This includes calculating the load for lighting, receptacles, appliances, and other equipment connected to the branch circuit. The general steps for branch circuit calculations are 1. Determine the load in volt-amps for each outlet or piece of equipment served by the branch circuit. 2. Sum the loads of all outlets and equipment in the branch circuit. 3. Apply any applicable demand factors as permitted by the NEC. 4. Calculate the branch circuit ampacity by dividing the total volt-amps by the voltage of the circuit. For example, a 120 volts 20 amps branch circuit can handle a maximum load of 2400 volt-amps. The NEC specifies minimum requirements for general lighting loads based on the square footage of the dwelling. These requirements ensure that there is adequate lighting throughout the dwelling. General use receptacles are typically calculated at 180 volt-amps per outlet. This value is used to account for the various appliances and electronic devices that may be plugged into the receptacles. Specific appliances, such as refrigerators, washing machines, and dryers, must be calculated at their nameplate rating. This rating indicates the maximum power that the appliance is designed to draw. For electric ranges and cooking appliances, the NEC provides specific demand factors that can be applied to reduce the calculated load. These demand factors take into account the fact that cooking appliances are not typically used at their maximum capacity for extended periods of time. The load calculation process involves several steps. First step is to determine the total connected load, which is the sum of all the individual loads that will be connected to the electrical system. The second step is to apply any applicable demand factors, which are multipliers that reduce the calculated load based on the diversity of the loads. The third step is to calculate the design load, which is the load that the electrical system must be designed to handle. The design load is used to determine the size of the conductors, overcurrent protection devices, and other components of the electrical system. In addition to the general load calculation requirements, the NEC also includes specific requirements for certain types of loads, such as motors, air conditioners, and electric heating equipment. These requirements are designed to ensure that these loads are properly protected and that the electrical system is capable of handling their unique characteristics. The NEC also includes requirements for emergency and standby power systems. These systems are designed to provide power to essential loads during a power outage. Emergency power systems are typically required for hospitals, fire stations, and other critical facilities. Standby power systems are typically used for commercial and industrial facilities to prevent business interruption during a power outage. In addition to the NEC, there may also be local codes and regulations that govern electrical installations. It is important to check with the local authorities to ensure that your electrical installation complies with all applicable requirements. The electrical system should be inspected by a qualified electrical inspector. The inspector will verify that the electrical installation complies with the NEC and local codes. The inspector will also look for any potential safety hazards. Applying Article 220.82b involves determining the total connected load of the dwelling unit, including general lighting, small appliance circuits, laundry circuits, and any other fixed appliances. The NEC provides specific requirements for calculating these loads. For example, general lighting is calculated based on the square footage of the dwelling, while small appliance and laundry circuits are calculated at a fixed value per circuit. Once the total connected load is determined, demand factors from Table 220.82 can be applied to reduce the calculated load. These demand factors vary depending on the type of load. For example, a demand factor of 100% is typically applied to the first 10 kV amps of the load, while a lower demand factor is applied to the remaining load. Article 220.84 provides a method for calculating the service or feeder load for a building containing multiple dwelling units. This calculation takes into account the diversity of loads among the different dwelling units. This involves determining the total connected load for all of the dwelling units in the building. This is done by summing the individual loads of each dwelling unit, calculated in accordance with Article 220.82b or other applicable methods. Once the total connected load for all dwelling units is determined, a demand factor from Table 220.84 can be applied to reduce the calculated load. These demand factors vary depending on the number of dwelling units in the building. For example, a demand factor of 45% may be applied to a building with 3 or more dwelling units. The demand factor is applied to the total connected load to determine the calculated load for the service or feeder. This calculated load is then used to size the conductors and overcurrent protection devices for the service or feeder. The NEC provides specific requirements for the size and type of conductors that can be used for electrical installations. The conductors must be sized to carry the calculated load and must be protected by overcurrent protection devices such as circuit breakers or fuses. The overcurrent protection devices must be sized to protect the conductors from overload and short circuit conditions.